Students, welcome to this second part of the chapter flow control statements, iterative statements. In the first chapter, we have discussed the need of repetition, range function, then for loop, while loop, jump statements in Python, and the last topic we discussed was the else part of loop. And if you have seen that video, then you must know that the else part of the loop only executes when the loop terminates normally. Okay, there are two types of termination using break and normal. So if the loop terminates normally, then only it will go inside that else part, otherwise not. Okay, so now let us move to the next topic, that is addition and multiplication series. So the addition and multiplication series, these are two types of series. Okay, so let us first see the addition series. The addition series will consist of numbers that will follow a particular pattern, and those numbers are separated by addition operator. For example, the series is 1 plus 3 plus 5 plus 7 ... up to n terms. So there is a particular relation between every two elements. After 1 there is 3, then after 3 it is 5, so the gap of 1 is maintained. So that's why it is called series. Okay, there must be a relation among the terms, otherwise you will not be able to solve it. Similarly, multiplication series will have some numbers following a particular pattern, but those will be separated by multiplication operator. Example, 1 into 3 into 5 into 7 ... up to n terms. So to find the sum of series, we will take help of the loops. Similarly, in the multiplication series, why? The question is why? Why we come to this decision that we will use loop? Because I have already told you that there are 4 parts of a loop. If these 4 situations are occurring in your program, then you will use loop. What are those 4? You will have a starting value, you will have an ending value, you will have some addition, you can say increment or decrement, and you will have something to perform. These are the 4 things. So if you see in this example, this is the initial value, this is the ending value, and you have to increment it by 1 plus 1. Okay, so there is an increment of 1, and you have to do something, that is, you have to perform addition operation at each step. So this means it fulfills the criteria of loop. Similarly, here also, lower limit, upper limit, increment, and body of the loop to be performed, that is multiplication. So all the 4 criteria of loops have been satisfied. That's why this problem will be solved using loop. Okay, so if we talk about addition series, then you will have to declare a variable called sum. You can change the name, but it is a good practice to have that name as sum, because you want to get the summation. So you will declare a variable sum that will have the initial value as 0, because it is additive inverse. Anything added to 0 becomes gives you the number only. That's why you will declare a variable. You can give it any name, but we are supposing that you will give it a name called sum, and that initial value will be 0. Similarly, in the case of multiplication series, you will declare a variable called multi. If you want to give another name, it's your choice, but its initial value will be 1, because it is multiplicative inverse. X into anything multiplied by 1 is the number itself. That's why we get the initial value as 1. So this is the difference in addition series, that initial value is 0. In multiplication series, the initial value is 1. Now inside the loop body for addition series, you will write a statement like sum is equal to sum plus particular variable value, that will be loop variable. While in multiplication you will write multi is equal to multi into that loop variable or a particular value. So what is this? That means the value of that variable sum is being changed at every step. Look at this example. First you will add, you will have this sum is equal to 0. Then you will add 1 to it. It will become 1. Then you will add 3 to it. Then you will add 5 to it. Then you add 7 to it, and so on. And similarly, following this process, you will get the final value of sum. Okay, that's why we have written sum is equal to sum plus some variable value. So sum is the initial value that we have taken as 0. Then this value will keep on changing with those numbers. Initially sum is 0, then 1 will be added to it, sum will become 1, then 3 will be added to it, the sum will become 4, then 5 will be added to it, then it will become 9, and so on. And after following this process up to n terms, we will be able to get the final sum of this series, and we will print the value of sum after the loop termination. At the end of the loop, after coming out of the loop, we will print the value of that variable sum to get the sum of series. Now a multiplication series, if you want to get the multiplication of it, then the product of it, then you will write multi is equal to multi into that loop variable or a particular variable. So multi is 1. Initially 1 will be multiplied by 1, giving value 1. Then it will be multiplied by 3, it will give value 3. Then it will be multiplied by 5, giving value 15. Then 15 will be multiplied by 7, and so on. And when we follow this process up to n terms, we will get the product of this series, and we will print the value of that product at the end of the loop. So this is how we add or get the product of a series. So there are two types of series: addition series, where all the numbers are being added, but the numbers must have a pattern between them. Similarly, multiplication series, you will multiply all the numbers that are having a particular pattern. Okay, so this was just the introduction that how you should go towards solving a problem of series, addition series and multiplication series. This thing you have to keep in mind, that what should be the initial value of that variable and how you should add to it. Okay, let us see an example. Suppose we have a staircase in front of us, and at each step some coins are there, and you have to collect all those coins at the end of the steps. You have to count how much money have you collected. Then what you will do is you will take a variable, that means a bag. The initial value of the bag will be empty, it will be empty. So as you keep on stepping over the steps, you will start collecting those coins in your bag. You will put them. So that is this line: sum is equal to sum plus loop variable. So you will be changing the value of your bag with addition of new coins. So after completing all the steps, you will count the number of coins in your bag. So it will give you the final amount. Okay. So I think this example will make it clear how this addition and multiplication series work. So it will be more clear when we will discuss the examples. Okay. Now, very important thing is nested loops. Nested loop means loop inside loop, one loop inside another loop. Okay. Here the inner loop must terminate before the outer loop. Okay, so the outer loop will be a larger loop and the inner loop will be a shorter loop. So the inner loop must terminate before the outer loop. For each iteration of the outer loop, the inner loop executes all of its iterations. Let us see it by example. If the outer loop has an iteration of m times, that means it has to execute m times, and the inner loop has to execute n times. So the total number of iterations will be m into n. How? Because for each iteration of the outer loop, the inner loop will run n times. Okay. So how many iterations are there of the outer loop? M. And the inside one is n. So for each value of outer loop, inner loop has to run n times. So how many values are of outer loop? M. So total iterations will be m multiplied by n. One thing that is to be noted here is the value of outer loop variable will change only after the inner loop has completed its iterations. Means after the complete iterations of inner loop, the outer loop will change one value. For example, in the clock suppose there are two hands, one for hour and one for minute. So after 60 ticks of minute hand, the hour hand ticks 1. Then the minute hand ticks 60 times, then the hour hand ticks 1. So this is how the nested loop works. The inner loop will move the given number of times. After its complete set of iteration, the upper loop will move one step forward. Okay. So the use of nested loops increases the dimension level of the output. If we have a single loop, it only signifies the horizontal dimension. It will just move further in a straight line. But if you add a loop inside another loop, it signifies the vertical dimension of the output. Okay, so the outer loop signifies vertical dimension, inner loop identifies horizontal dimension. Okay, so if you have been given a two-dimensional structure or a pattern to print using programming, then you must use nested loops in it. Okay, so that pattern is to be broken in two components. One is horizontal component, one is vertical component. The vertical component will be taken care of by the outer loop, and the horizontal component will be taken care of by the inner loop. Okay, so the main task in nested loop is to establish the relation expression between the inner and outer loop variable. Okay, because the outer loop is containing inner loop in it, so there must be a relation between the loop variables of the outer loop and the inner loop, and that relation becomes the condition of the inner loop. Okay, it might be sounding very tricky to you, but when you see the examples, it will be clear to you. But before doing the examples, you must be clear with the basic theory of it. That's why I have written so many points for you, so that you are clear with it. The relation between the inner and outer loop, because if they are not related, they cannot be inside each other. Okay, they have to be related. There must be a relation between the outer loop and the inner loop. And you know that the loop works on loop variables. So there must be a relation between the loop variables of inner and outer loop. And that relation will be the conditional expression of the inner loop. You know, there is a condition expression in a loop. There are 4 parts of a loop. First one is initialization, number 2 condition, number 3 body, number 4 modification. So the condition part of the inner loop will be the thing that will show the relation between the loop variables of upper and lower, that is inner and outer loop. The outer loop will be used to move through the required number of steps. That means vertically. It will move vertically. Whereas the inner loop will be responsible for actual pattern generation, that is horizontally. Okay, so if you have a pattern that is having 2 dimensions, one is horizontal and vertical, then the vertical dimension, that means changing of steps, will be taken care of by the outer loop, and actual printing of loop, that is horizontal dimension, will be taken care of by the inner loop. Clear? So please go through these points again and again until you are clear. It is very important because these questions of nested loop are very tricky. So you have to understand all these points. If you understand all these points, you will be very quick to write such programs of nested loops. Now we come to hybrid series. In the beginning, we have seen two types of series, addition and multiplication. So the combination of these two series becomes hybrid series. Let us see an example. 1 plus x square plus x cube plus dot 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 up to x to the power n. How it is a hybrid series? Please see. This term x square x cube, this is a multiplication series. Why? X cube means x into x into x 3 times. So it is a multiplication series, obviously. Similarly, this x to the power n is x into x into x n times. So the same step is being repeated a particular given number of times. That means loop. So it is this term is in itself is a multiplication series. Each term is a multiplication series here, and you find this plus in between all these terms. So it is also a addition series. So it is a combination of addition and multiplication series. That's why we call it a hybrid series. Clear? So the final sum of such series can be obtained with the help of nested loops. Why nested loop? One loop for multiplication series, one loop for addition series. And please tell me which loop will be outer and which loop will be inner. Okay, let me tell you. Is the main thing, that means at the things that has to be repeated at each step should be inside. So what you have to do at each step? You have to calculate the power. This means the multiplication series has to be executed again and again. So this part should be inner loop, and the outer thing is just to add, nothing else. So the loop of addition will be outer loop. The inner loop will be used to get the task of you will be used to do the task of getting the product term. X cube means x into x into x. This is a product term. So to get it, you will have to write a loop, that is a multiplication series. Okay, so this will give you a product term, and this outer loop will add that product term to the final sum. Okay, and it will also move to the next element. So how? First it will calculate 1 plus x, it is okay. First it will calculate x. X can be written as x to the power 1. Okay, then this value of x will be added to 1. Then it will calculate x to the power 2. The inner loop will calculate x to the power 2, and the outer loop will add this x to the power 2 to the previous sum. Then the inner loop will calculate x to the power 3. Then the outer loop will add this value obtained by this inner loop to the previous sum, and so on. So you will get the final sum at the end of these n steps. So after the completion of the outer loop, the final value of the sum term is printed. Clear? Here we have combined two series, addition series and multiplication series. So the logic of those should also be combined, and the logic says that if it is a summation series, you have to declare a sum term with 0, and you have to declare a multiplication term as 1. Okay, so where to declare them? Let us see in the last point. The additive term named sum, that is mostly initialized with 0, should be initialized before the outer loop. Okay, before the beginning of outer loop, you have to initialize that sum variable with the actual value that you want. And the product term named multi, that has to be initialized by 1, that should be initialized between the body of outer loop and inner loop. Means before entering the inner loop, you must initialize that multi with 1. Why? So that its value gets initiated to 1 for every iteration of outer loop. Means, so when you calculate x to the power 2 and you move to x to the power 3, again that value of multi should be initialized to 1 again. For this is a complete multiplication series, so you require the value of multi as 1. After it, when you calculate x to the power 3, again you want the value of that multi variable to 1. So that variable multi is equal to 1 should be written between the two loops. That means between the upper loop and the lower loop, inner loop and outer loop. Before the body of the inner loop, you must write the initialization statement of multi, and you must write the proper basic initialization of that sum element before the outer loop. Clear? This theory part must be clear before going to working with these practical questions. Now let us see some solved examples. The first question is to print a table of a number up to 10. Now let us see how this question is related to loop. Okay, let us take an example of a number 2. What is the table of 2? 2 into 1, 2 into 2, 2 into 3, 2 into 4 and up to 2 into 10. So the same operation 2 into 2 into 2 into is being executed 10 times. That means loop. Let us cross check that there are 4 parts of a loop. All of them must be present. Are they present? Let us check. Is there any initial value? Yes, 1. Is there any final value? Yes, 10. You have to move up to 10 terms. Is the same task is to be repeated again? Yes, 2 into 2 into 2 into this is the same task. And is there any increment or decrement? Yes, 2 into 1, then 2 into 2, then 2 into 3. So how you can write a generalized term for this 2 into 2 into 2 into? You can write it like 2 into I, where I ranges from 1 to 10. In set theory, you have studied these terms. Okay, 2 into I, where I ranges between 1 to 10. So this is the loop. So how you will write it using a while loop? So first you will enter the number from the user. You will get it in n. First phase is initialization. So what is the initial value? 1. So you have taken a variable I. This is a loop variable. Initial value is 1. So you have to go up to 10 terms. So the condition becomes while I is less than equal to 10. So this is your condition term. That means you have to move 10 steps. Now what you have to do? You have to print 2 into 2 into 2 into. That means now here it is n. So if the number is n and you have to print the when the number was 2 and you have to print the table of 2, what was the general term? You said that print 2 into I, where I moves from 1 to 10. Now the number is n. So what you will say? Print n into I, where I ranges from 1 to 10. Same thing is here. The range is from 1 to 10. This is lower limit. This is upper limit. Condition. Okay, so this is initialization. This is the condition. Then colon, then the main body. What you have to do? You have to print n into I. And after one value of I, you have to increment the value of I by 1. So at the first step, you will get n into 1. Then I will become 2. Then you will get n into 2. Then after that, you will get n into 3, and so on. So you will get the table of any number you enter as n. Clear? Very simple example. Now, let a bit complex multiplication series question. X to the power n. Write a program to find x to the power n. Here we have two variables. Whenever you find these terms like x, n, a, b, m, n in your program, that means those values have to be entered by the user. Please note. Okay, if you find some alphabets in your program, like write a program to find x to the power n. That means the values of x and n will be taken from the user. It will not be provided by you. If the program is like write a program to find 2 to the power 3, then you should not ask the user. Then you should set the value of x to n, value of n equal to 3. But if it is a program like x to the power n, that means you have to ask the user about the values of those alphabets. So you will ask the value of x, you will ask the value of n. Now I have told you that x to the power n is equal to x into x into x into x n times. That means it is a multiplication series. And if you remember the logic of multiplication series, it says that you should take a variable multi and its value should be 1. Okay, and you have to perform this using while loop. So you will have an initialization statement of loop variable. So here we have taken the loop variable as I and the initial value is 1. Now you will move up to n. Why? Because x to the power n is equal to x into x into x into x n times. Okay, so x into x into x into x and up to n times. So the condition becomes that I less than equal to n, because you have to move n times. And what you have to do? You have to do x into x into x. That means the next logic of multiplication series, multi is equal to multi into x. Why x? Because you have to multiply x again and again. You are not multiplying any other thing. You are just multiplying x again and again. That's why multi is equal to multi into x. And after it, you will increment this loop variable. The entire loop depends upon the loop variable. Okay, so because the loop variable is the main thing that initiates it, that takes it forward up to the upper limit. So you have incremented I by 1, and that's how you get the multiplication. And after that, at the end, you print this multi. I have not given a message in it. You can give the message. What should be the message? Print the value of x to the power n is multi. It can be like this. Okay, so that's how you get the value of x to the power n. So these were two examples of loop, while loop. Now let us see some examples of for loop. The first example is to print even numbers up to 100. That means 1 to 100. Now you must remember the range function. Okay, that generates a sequence, and you know that for works on sequence. For variable name in a sequence. This range function generates a sequence. The important thing of range is it moves up from lower limit to upper limit minus 1. That's why we have put 1, 101. Not 100, we have written 101, because it will move from 1 to upper limit minus 1. Clear? So I will start from the value 1 and it will move up to 100, because we have not specified the third term. Okay, so the increment will be of 1. Okay, you know that there are three types of range function. Range function having 1 argument, range function having 2 argument, and range function having 3 arguments. The first argument is, if it is having only 1 argument, then it will be what? Upper limit only. If it is having 2 arguments, then the first one will be lower limit, second one will be upper limit. If it is having 3 arguments, then the first will be lower limit, second will be upper limit, and the third will be step. Because you want to check every number, so you can write 1, 101. The third value is not there, so the step value will be 1 by default. So the value of I, that means the loop variable, will be in a sequence. What will be the sequence generated by this? There will be a sequence 1, 2, 3 dot up to 100. So the first value of I will be 1, then it will be 2, then 3, then 4, and so on. So you will check if I mod 2. This is the logic for checking even number. Any even number when divided by 2 gives the remainder 0. So to check the remainder, you have percentage sign, that is called modulus sign in Python. So you write if I mod 2 equal to 0, then you print I. So that's how you get all the even numbers between 1 to 100. There is another method to solve this question using that step value that you can think of, and you can write that program also. Okay. If this program is having 3 lines of code, that program will just have 2 lines of code. The same program using the step value. The range function having 3 arguments. Okay. Try to solve this question. Try to figure out how you can solve this question using that step value, and that program can be done in just 2 lines. Now, next question. Program to find out factorial of an integer. I think you know factorial of a number. A factorial of a number is the multiplication of all the numbers from 1 to that particular number. So suppose you want to calculate the factorial of number 3, then it is 1 into 2 into 3. Similarly, the factorial of 5 will be 1 into 2 into 3 into 4 into 5. That means this is a multiplication series, simple. That means you have to apply the logic of multiplication series. What is the logic? First, you will get the number as input. Next, you declare a multiplication variable. Here we have changed the name to fact for factorial. So you initialize this fact with 1. Then you go from 1 to n plus 1. Why? Because you know that factorial of n will be 1 into 2 into 3 into 4 dot 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 up to n. So 1 to n. Simple. The 1 is lower limit, n is upper limit. So you will start from 1 to n plus 1. Range function goes 1 less. That's why for I in range, I is the loop variable that will move the loop in range 1 to n. What you have to do? You have to multiply. You know the logic of multiplication series. Multi is equal to multi into something. Here the variable name has been changed fact for factorial. Fact is equal to fact into I. Why I? Here you can see multi is equal to multi into x, because x was being multiplied again and again. X to the power n is equal to x into x into x, nothing else. But here factorial of n is equal to 1 into 2 into 3 into 4. Every time the value is changing. The changing value can only be the loop variable, because it is the only changing value. That's why it becomes fact is equal to fact into I. And after the termination of this entire loop, you will print the value of fact, which will give you the factorial of that number. Clear? Great. Next example is to check a number for prime. A prime number is the number that is only divisible by 1 in itself. Okay. So here we get the number from the user. Then we apply a loop for I in range 2 to n by 2. Here we have a logic that a number can only be fully divided by its half only. Suppose the number is 100, so it cannot be divided by any number which is greater than 50. So you have to move from 2 to 50, because every number will be divisible by 1, so you cannot start the loop from 1. Okay, so this is a practice of students where they are at fault. They start this loop from 1, because if this loop starts from 1, each number will be declared as not prime, because every number can be divisible by 1 and itself. So you must start with this loop from 2, not 1. And you do not have to go up to n, because no number greater than the half of its number can divide that number completely. If the number n is 100, so you cannot think of any number greater than 50 which can fully divide it. Okay, so you have your loop moves only up to n by 2. Why we have put this floor division? Because we just want integer values to be divided at the denominator. This floor division gives the only integer values. So the loop value of I will start from 2, then 3, then 4, and on up to n divided by 2. So you will check that I is ranging from 2 to n by 2. So you will divide this value n by each value of I, n mod I. So n, that is the value to be checked. If it is divisible by any number between 2 to n by 2, that means it is not prime. And if it is not prime, means if it has been divided by a number, that means it is not prime. Then there is no need to divide it by the remaining numbers. Suppose you have a number 8 and you divide it by, in the beginning the value of I will be 2 because the loop starts from 2. So if you write 8 mod 2, so divide 8 by 2, what will be the remainder? 0. That means 8 is not prime number. Then why you should divide it by 3 again? If it has been divided by 2, you should stop because 8 is not prime. So you should not go forward up then to 3, then to 4. So it is a waste of time. So as soon as your number is fully divided by any number between 2 to n by 2, you just print not prime and break out. Here you use the break statement, the jump statement we have discussed in the previous session. You break out of the loop, means you will just move out of the loop here. And here we have used the else part of loop. You know, the else part only executes when you complete the loop normally. But here, if you will break out, this else part will not be executed. So, if your loop is breaking out, that means your number is not prime. And if your loop is completing itself normally, that means the number has not been divided by any number. That means that is clear indication that the number entered by you is prime number. Very easy. Okay, that's how you write programs using loop. So any program of loop will have 4 things in it: initial value, final value, a particular increment or decrement, it should be same, and something to be performed. Okay, so keeping in mind this point, you can check whether the program will be done using loop or not. Okay, so let's move forward, and these are some practice programs for you. You have to check an integer for Armstrong. Armstrong numbers are the numbers for which the sum of cube of its digit, sum of the cube of the digits equal to the number itself. Those numbers are called Armstrong. Then to check a number for palindrome. What is a palindrome number? The number which is same from both the sides. For example, 1 to 1. Okay, from both the sides this number is same. That is called palindrome. Then to find out the sum of n natural numbers, sum of digits of a number. Okay, then you have to print 20 terms of Fibonacci series. Fibonacci series is a series when the third term is equal to the sum of first 2 terms. Okay, so this is a pattern here. So whenever there is a pattern and there is a lower and upper limit, that means there is loop. Next question, to print all the prime numbers between m to n. This is a nested loop question because one loop is to be used for prime number checking, another loop is to be used for taking the loop from m to n. That means This is nested loop. The outer loop will take you from m to n, and the inner loop will check each value between m to n for prime. Next, Armstrong numbers between m to n, same nested loop question. Third, palindrome numbers between m to n, nested loop question. Now we have some sum of series question. These are hybrid series. 1 square plus 3 square plus 5 square dot dot up to n square, x plus x square upon 2 plus x cube upon 3. You must note that each step will have some relation. That means the terms must have some relation. See that if it is x square, then in the denominator you have 2. If there is x cube, then in denominator you have 3. So there must be a particular relation between because this will constitute loops. This will be using inner loop, the outer loop will be for addition. Similarly, we have x minus x square upon 2 plus x cube upon 3 and so on. Then we have 1 plus x square upon 2 factorial. This is the sign for factorial. So this is a question having 3 loops. The outer loop for addition, there will be 2 inner loops, one for calculating x to the power n and another for calculating n factorial. Okay. So this is the question of summation of series. Okay. I will provide you some solutions, the solutions for some of these questions as the attachment, and I will give you the link in the description, and you can check them out, and then you can try more questions. You can try more questions from your book also. Okay. Now, these are the practice programs for pattern. I have discussed the patterns, the 2D patterns in the theoretical session, that if you are having a 2D pattern, then you will use nested loops. One loop will be horizontal and one for vertical. So these are the loops. One, this is called star pattern, half pyramid, inverted half pyramid, hollow. These are number patterns. Okay. So all these patterns can be printed using loops. Okay. One loop will take care of this vertical, and inner loop will print these patterns. Okay. So you have to divide your pattern in horizontal and vertical components, and you can print these patterns using the nested loops. Okay. So this was all about the theoretical portion of this chapter. We will have a separate video where we will be discussing these programs. Some of these programs will be discussed. The actual program implementation will be discussed, how to run the programs, and we will also cover some of these patterns there, that how to write a program for a particular pattern. But before that, you must be clear with the theoretical concept of this looping constructs, that is iterative statements. So you must go through these two videos, the first portion and the second portion, so that you are clear with the theoretical ideas, and you should also check these solved example so you can get an idea how loops are done. Looping is very important. It is if you cannot understand the theoretical concept, it becomes very tough to understand, and if you are able to understand the theoretical concept, it is very easy. So if once it comes into the mind, it becomes very easy to draw these patterns or write a program for any of these questions or any other these summation of series. But you have to get the general idea of loop, that loop has 4 parts. First, there must be a lower bound, that is initialization. Then there must be an upper bound, that is your bounding condition. Then there must be an update, that means increment or decrement. And then the fourth thing, that is the body of the loop, means the steps to be executed. If you can find these 4 things in a program, then that program can be done using loop. So in the next video lesson, we will be covering the practical aspects of these programs. And before that video, you must be clear about all the theoretical points. Okay, so please go through these 2 videos, and we will be meeting in the next video lesson.